In the previous class, we were describing about the Newton Rapson method for very one equation, one nonlinear equation. If there is a one nonlinear equation, how to solve it by Newton Rapson method? This we were describing in the previous class. Now, and this was the case that if the equation, just to review of that, what we were described above, just to review, we assume this is a equation. It is a nonlinear equation. This say it is a x square plus 2x plus sin x is equal to c. C is given. Then we find what is the value of x. So in this we assume the value of x, that is the estimated value here. Then estimated value plus error is called the actual value, and this error is obtained by with the help of Taylor series when we expand it. And from here we find this delta x error is equal to c, means the given value here, non-value c, minus fx0 means calculating this function, calculating this by estimated value. So if you put x is equal to x0 here, we will get something else than the c, because this is not a correct value. X0 is the estimated value. So fx is the estimated function value minus the value of the function. And this is the differentiation of the function with respect to x, and putting the x is equal to x0 in this. In this we find the error, and this error, when added to the estimated value, we get the new value. And it is repeated. Now in the second time, in the second iteration, we consider estimated value equal to x1, not the x0. Then in the third iteration, x2, then x3, they go on increasing, and we go on approaching to the correct value. This we described yesterday, and this was the nonlinear equation, and there was only one equation. Now if there are more than one equation, say there are three equations here, or there are n number of equations in the power system, there might be number of equations. And so let us have more equations. Say here in this example we have taken the four equations, and these are the four equations. Equation means non-linear equation. They are the function of x2, x3, x3. जैसे आपका in your case the your equation will be the function of p, q, v, active power, reactive power, and voltage or angle. There can be four variables and number of equations depending upon four equations, two equations at each bus, and if there are 20 equations, 20 buses, so 40 equations will be there, except the slack bus. So means reducing the slack bus. So in this way, the number of nonlinear equations, which might be consisting of sine, cos, theta, etc. But here similar type of nonlinear equations are there. This is some constant value. Then again the same procedure we apply as we applied in the single equation, and we whatever is to be calculated, that is here in this case x2, x3, x4 are to be calculated. So we estimate these values, we assume those values. Estimation means with some another analysis, or with some understanding, we predict that the value of f2 might be this, value of x3 might be this. Say if it is a voltage, it should be near about 1, so we will consider it as a equal to 1. If it is an angle, we consider it as equal to 0, or better also that if we perform later on, okay, that we will describe later when we will take the powerful analysis. But we estimate the value of x2 and x3. Let x2 is equal to x2 0, x3 is equal to x3 0, and x4 value of x4 is x4 0. And in estimating this, the correct value is x2. So x2 minus x2 0 is the error, and that error is represented as del x2. So del x2 is the error. So adding error into estimated value x2, we know the x, means x is equal x2 is equal to x2 0 plus del x2 0, means estimated value plus error is the actual value. So it is the actual value. Similarly, x3, x4 means we assume the value of estimated the value of x2, x2, x3, and these are the error. So putting error plus estimated value is the actual value, and this is equal to c. This value is known to us. This is also given. Similarly, equation others 2, 3, 4. So in these equations also we put all. Now similar to the like this, we apply the Taylor series here also. In the one equation, it was in the Taylor series. While expanding the Taylor series, we make the differentiation of f. F is the function. F is differentiated with respect to x, because f is a function which is a function of x. F is the function of x. But in this case, f is the function of x2, x3, x4. More variables are there. So we, in place of differentiation, we will do the partial differentiation. Means while doing partial differentiation means we will differentiate this with respect to x2, we will differentiate this with respect to x3, with respect to x4. While differentiating with respect to x2, the x3 and x4 will be considered as a constant. Similarly, while differentiating f3 with respect to other than x3, it will be considered as a constant. While differentiating with respect to x3, we will assume x2 and x4 as a constant. Similarly, the x4. In this way, now we do the expansion like this. Means the if we apply the Taylor series, means first initial estimation value we know x2, x3, x4. So value of x, value of function with by putting the value of estimated value, we will get this f2. Means this is calculated. Now derivative of x2 with respect to this derivative of f2 with respect to dx2, then derivative of x2 with respect to x3, then derivative of x2 with respect, means we will make the derivative of f2 with respect to x2, x3, x4. In the Taylor series, only this term was there, means del f del x is equal to df by dx. Only the x was there, but here in place of x there is x2, x3, x4. So f2 will be different, or f will be differentiated with respect to all, with respect to partial differentiation with respect to x2, partial differentiation with respect to x3, partial differentiation with respect to x4. So in this way we will do. Then the second order term here also will be neglected. Otherwise, it will be delta x divided by factorial 2 and square of this. So is anybody joining again? Who is this? Renu. Okay. So here now see the estimated value of f2, then partial differentiation of f2 with respect to all. Then the higher order term is del x square by 2 factorial 2, then square of this, del x square by 3, square of this, then this. So what higher order terms, we neglected in the previous example, previous case also. Here also the higher order term are neglected here. Similarly, derivative of f3 with respect to all, the value of f3 by putting the estimated value, then partial differentiation of f3, this partial differentiation of 3 with respect to all x2, x3, x4. Similarly, partial differentiation of f4 with respect to all variables x2, x3, x4. This is the expansion first order term. Then there is a second order term. There the square of this term will come. Then the third order term. But the second order and third order terms, since we have considered del x is the error and this is a small error, so that second and third order term are neglected here. And these are the known value. These are the given value C2, C4. So this equation, these three equations you can write in the matrix form like this. You can write this into the matrix form. All these three equations can be written in the matrix form like this. Who is coming too late? Narveer. Why are you too late, Narveer? Anyway, so these three equations we write into the matrix form, means this is the value, function value f2, f3, f3 by putting the estimated value. So this is calculated. This is already known, all already given, C2, C3, C4. These are the partial derivative by initially partial derivative and putting the value of the x2, x3, x4. And this is the error now. So here we calculate del x2, del x means the error in the estimated value of x2, error in the estimated value of x3, error in the estimated value of x4. जो हमने x की वैल्यू एज्यूम किया है उसमें क्या एरर है, दैट वी कैन कैलकुलेट फ्रॉम दिस इक्वेशन. बट हाउ? टेकिंग दिस c2 माइनस दिस, c2 दिस इज गिवन, दिस इज कैलकुलेटेड. ये भी आपने कैलकुलेट किया, इसको इधर ले जाएंगे तो इट विल बी लाइक दिस, C2 minus F2 0, C3 minus, because this is given, this is calculated. Okay. So, and this is it is called the Jacobian matrix. So this is the inverse of Jacobian matrix. How it is calculated? By taking the partial derivative of f2 with respect to f3, partial with respect to all variable, partial derivative of f3 with respect to all variable, partial derivative of f4 with respect to all variable, and putting the value of estimated variables. So in this way, we know this, we find error. Once we find the error, what we will do? This error will be added into the estimated value, means x1 x means first iterated value of x2 will be the x2 plus this, x3 plus this, x4 this, means x2 x3 x4 adding this is the so this is the now value of error. And in the first iteration we can know the estimated value plus error is the first iterated value, and those first iterated value can be assumed as a now initial value. Again do the same process. Now estimated value consider equal to the now estimated value consider here, and the equation will be repeated, and again we will get then x3, then we will get the second iteration, third iteration, and fourth iteration continuously till the two consecutive values are nearly the same, then we stop. So this method is based on the how estimation is done in the starting. If estimation in the starting is done good, then system will converge very fast. Within 2-3 iterations, the system will converge. If by mistake, if you take in the wrong estimation, then it can reverse also in place of conversion. So it will be slow. Otherwise, it will be slow. So it is the inverse of the Jacobian matrix. This is the vector actual value minus the estimated value. Actual value minus the estimated value. So this is the error. We repeat it again and again. I hope this method of fast decoupled method of solving the nonlinear equations we are able to explain. And now in place of this value x2 our variables in place of x2 x3 x4, our equation in place of f2 f3 f4, our equations are the real equations, and real equation means power flow equation. In the power flow equations, equation of p is like this, means some buses, we know some buses, first bus is the slack bus, some buses 2 to m are the PV bus, and some buses that is m plus 1 to the PQ and are the PQ bus. So wherever there is a PV bus or PQ bus, P is known to all. When P is known, देखिए यहाँ क्या था, C2 known था, C2 3 C4. Here the P2 P either PV or PQ, P is known from 2 to n. We know the P means P2 P3 P4 Pn. We know every P. So P is known. This value is given or this value is known at each bus. Suppose bus number 2 if it is a 30 bus system, bus number 2 to 30, select bus is okay, and rest of the 2 to 30 P is given. So this is given, and equation for this is, we know, we have earlier obtained. This is the equation for P. This equation is a nonlinear equation. You see, it is the function of angle, cos of angles. This is cos and these are the angle, and here it is a admittance. This is again a complex number. So this is a complex number. This is the magnitude, not complex number is not there. Complex because of this is the amplitude and complexity of the angle. It means it is magnitude and angle. Angle has come to this. So it is a actual number, real number, and this is sigma p to 1. The number of such terms are there. Means this p2 is the number of such terms are there. If it is a 20 bus system, so this will have the 20 terms. Because it is p equal to 1 to n, so 20 terms values are there. So p2, 3, p4 is known. Now some buses are pq buses m plus 1 to n. So what is given? P and q is given. In those case, p and q is given. And we have already taken q. Equation of q is this. Equation of q is again, it is a function of sine theta. These are the magnitude and this is the angle. And this is again, if it is a 30 bus system, the 30 terms will be here. So this qm plus 1, qm plus 2, qm plus 3 up to q n plus m number of buses will be there. Means up to n plus 1 to n. Means n minus m plus 1. n minus m plus 1 number of such buses will be there. So all these equation means what is known? All p are known और m plus 1 से n तक आपका q known है. All these equations you can write into the, we can write the equation of p like this is the expansion of p. Otherwise we know this is the expansion of p. Similarly the expansion of q, this is the expansion of q, your cos theta, your sin theta. This is the expansion for 3-bus system. If there are 20-bus system, then accordingly number of terms will be there. So all these equations put together in the matrix form, as we did here, you see, as we did here, all those equations, you see, all these equations here, all these equations, when we put into the matrix form, this is all these equations, when we put into matrix form, it is like this. Similarly here also, if you put all these equations into the matrix form, which we have just explained, it will be like this. These are the known value. देखिए वहां से आप कंपेयर करिए, C2 था, C2 minus F2 and Jacobian inverse, then it was the del x2 del or variable x2, x3, x4. Similarly, the known values mean P2. Here in place of C2, the P2, P3, Pn are known, given, and Qm plus 1 to Qm, Qn. मतलब m plus 1 से लेके n तक क्या है, PQ buses है. तो Q is given here and P is given for all except the slack bus. So P is known, this Q is known, and this is calculated by putting the estimation values of P, D and delta. We calculate this. So this can be obtained by multiplying the Jacobian inverse into this. And what is this? ये क्या है जो इन्हीं का देखिए आप, you again you see this equation. This equation, ये हमारा P2 था, this P2 का डेरिवेटिव विद रेस्पेक्ट टू ऑल वेरिएबल, ये P3 का डेरिवेटिव विद रेस्पेक्ट टू ऑल वेरिएबल, ये Q3 का डेरिवेटिव विद रेस्पेक्ट टू ऑल वेरिएबल. सिमिलरली यहाँ सिमिलरली क्या होगा, सिमिलरली इट विल बी हियर दैट P2 विल बी पार्शियल डेरिवेटिव ऑफ P2 विद रेस्पेक्ट टू ऑल वेरिएबल. जितने भी वेरिएबल क्या है इसमें, जो अननोन है, देखिए P2 इज नॉन, देन व्हाट इज अननोन, P is known, so then delta is unknown and Q is known, then voltage unknown. If it is so here P2 to Pn, the delta is unknown, so these are the delta. So all variable delta 2, delta 3, delta n, then all voltages Vm plus 1 to Vn. So P2 is the function, P2 is the derivative of P2 with respect to deltas and with respect to voltages m plus 1 to n. Similarly P3 with all variable, then Pn with respect to a variable, then this is Q, Qm plus 1 to this Qn, here it will be Qn with respect to all variable, then Qm, then Qn with respect to all variable. So in this now this is difficult one, that calculating the inverse Jacobian, this is difficult one. So for example, let us have, as I told, if it is 30-bus system, and out of 30, 50% are the PV bus and 50% are the PQ bus. Let it be there. So it means if it is 30-bus system, so 2 to n. 2 to n मतलब क्या होगा, ये 14 हो गया up to here 14, और ये क्या हो गया up to slack bus and PV bus are the 15 and rest are the PQ 15 ये. So 15 ये and 30, 29 ये. So what will be the size of this? Size of this will be 44 by 44. For 30-bus system, size will be 44 by 44, and each P is the derivative of all variables. P अगर आपको 30-bus system है तो P2 will have the 30 terms. इसमें 30 terms होंगे, and each term will have the sinusoidal function. So no doubt it is very difficult to obtain the partial derivative of each term. देखिए ये कितने हैं, 44 by 44. You think how many number of terms are there? ये 44 by 44 means कितने हो जाएंगे? If it is 40 by 40, so 1600, and 44 by 14, so it can be nearly 1800, for example. So if there are 1800 terms, and each term here P2 is having 20 terms, so getting all the derivative of this partial derivative of all these is very difficult. Then finding the inverse of this 44 by 44 is very difficult. And after that, this is for one iteration. because in the next iteration, this is the unknown value, we will get this. If you add this value of the estimated value, means delta 2 and this will be the delta 1, then delta 3, delta 4, and this is the first iterated value, not the exact value. Then second iteration, third iteration, even if you take the 5, even if you take the 5 iteration, how many times of differentiation we will be doing? So it is very difficult. That's why there is a need of our system is like this. Practical power system is like this. It is not about the 30, it can be 100 by 100 per system. So it is very difficult to solve this. That's why we need a computer application in power system. And without the computer, it is not possible to find this. That's why it is needed. And big system, you will find Newton Rapson method is preferred in place of Gauss-Seidel method. And the this technique of finding the y-bus, then finding the Jacobian inverse, then multiplying this, everything is done under Newton Rapson method in the MATLAB programs. Now you remember these terms. This P2, these are the, you see, this is called the J1. You can divide into 4. The size of this is n minus 1, because from here P2 to Pn, it is P2 to Pn. So size of this is n minus 1. So n, this is n minus 1 by n minus 1. This you see n minus 1 by n minus 1. It is called J1. And this you see n minus 1, n minus number of rows are there. And this column will be how much? The column will be equal to this n minus m is the this, because it is from m plus 1, so n minus m will be this. So n minus 1 rows and column will be the n minus m. So the size of J2 is this, n minus 1 is this. Similarly, size of this n minus m into n minus m. You know, size of this is n minus m, so this is n minus n. So this, so the 1, 2, 3, 4, and size of this will be the n minus 1 into n minus m. So sorry, n minus m into n minus 1. So these are the 4, J1, J2, J3, J4. And here also one similarity is there. While doing this, there will be one similarity. That similarity means we will find some technique of obtaining the partial differentiation of this. And we certainly are not going to do the partial derivative of all these terms. Say it is 60 by 64, then 1800 terms, 1800 these derivatives are there, the equations are there. We are not going to do the partial derivative of 1800 equations. We will get some similarities. Let we have out of this J1, they all are the function of P and delta. ये देखिए यहाँ से यहाँ तक P and delta. Means we will make the derivative P with respect to delta. Further, there is a similarity that this is it is a diagonal which having the P2 by D2, P3 by D3, P3 by D3, delta 3 and Pn by delta n, like the diagonal element. And off diagonal element means ऊपर अगर 2 है तो 3, means I and K, like this, or I or P, del P2 by I, del delta by P, del delta P. So this is a diagonal element, similarity of diagonal elements, again similarity. Here I, then it can be P. Similarly, the P with respect to delta, this is a partial derivative of P with respect to voltage. And this again diagonal element or off diagonal elements. And here also you see, in case of a diagonal element, M1 and M1, N and N, of diagonal element, here I, then here it is a P. So we will take the benefit of this similarity to find the partial derivative of all those equations. One more thing, before obtaining the value of J1, J2, J3, J4, we do some more modification in this basic matrix. This is our basic matrix. If you remember, the same matrix is there, only difference is here also you see the same P2 to Pn, here Qm plus 1 to Qn, same equation, same this left hand side is there. On the right hand side it is the same, only thing is here it was the del P2 by del V voltage m plus 1. Now since voltage is in per unit, so get a change in voltage with respect to per unit seems to be better option to calculate. That's why we divided it by per unit value. इसको Vm, del Vm divided by Vm1. So change in voltage per unit voltage can be obtained. Del Vm divided by Vm, and this here it is divided, so here it is multiplied, because this row is going to multiply by this column. So this m plus 1 will be cancelled with this m plus 1. Similarly, this Vn will be cancelled with this Vn. Similarly, here also. Here you see everywhere here Vm plus 1 added, here multiplied, and here it is divided. Similarly, like this. So this is done. Only this slight modification is done. Otherwise, equation is same. Now, our intention is to find out these value 1, 2, sub. These are the this is called the Jacobian matrix, and the sub matrix of this is sub matrix of Jacobian are, they are called H and JL. This will be considered as H. This will be considered as N. This will be named as J. This will be named as L. So H and J L, and we know size of this. What is H? N minus 1 by into n minus 1, n minus 1 into n minus m, n minus m into n minus m, n minus m into n minus n. So these are the size, and again H will be like this. Pi by delta I, HII means this diagonal element of diagonal element. We have to calculate this and this. Similarly, in case of a n, you see n here INP and INI means diagonal and off diagonal. Similarly, here in J, this J, Q with respect to delta P means Qi by delta I and Qi by delta P. INP here Qi with respect to voltage, this is H, Q with respect to voltage, or means IN both side in the diagonal element N and N, and here in the off diagonal element it can be N, it can be M plus 1 means it can be I, then it can be P. So now you see, after making some similarities, after observing some similarities, there will be only the two term will be here, 2 here, 2 here, 2 here. So there are 8 terms. So we will write the equation for the 8 terms. 8 equations we will write, and we will do the partial derivative, and those value of partial derivative we can write in the Jacobian here, so that then taking the inverse of that will be simple. Then that will be calculated, and taking the inverse will be simple. So our next target will be to find the value of these variable. Okay. So before going to next, we would like to know whether any query is there up to now. यहाँ तक जो एक्सप्लेन किया उसमें कोई क्वेरी है?